Have you ever stopped to think about how your body manages its energy? It's a pretty complex system, but right at the heart of it, there's this really fascinating puzzle. We're going to dive into how two major players, your liver and your muscles, handle the exact same fuel, sugar, in completely opposite ways.
So here's the core mystery for today. Your liver, it acts like this generous community bank, sharing its sugar with your entire body. But your muscles? Oh no, they hoard every last bit for themselves. So what's the deal? Why the huge difference? Well, as you're about to see, the answer is actually surprisingly simple and pretty brilliant.
All right, let's meet our two main characters in this story. On one side, you've got the liver. We'll call it the body's generous giver. It's the central hub for blood sugar. And on the other side, we have your muscles, the body's selfish user. Now, I know selfish sounds a little harsh, but trust me, this behavior is absolutely critical for what muscles do, which is, get you moving when you need to move.
Now, both these organs store sugar, but they pack it away in a form called glycogen. And to get the energy out, they both use the exact same process. It's called glycogenolysis. Yeah, it's a mouthful, but it just means breaking down stored glycogen to release energy. So far, so good, right? They both start on the exact same page. But it's what happens next that changes the entire story.
And this is where their paths completely split. When the liver breaks down its stored sugar, the final product is just plain old glucose. And this glucose can freely hop into the bloodstream and travel anywhere in the body it's needed. But when your muscles break down their sugar, they produce something slightly different, glucose 6-phosphate. And here's the critical part. That little addition, that phosphate, acts like a lock. The sugar is now trapped inside the muscle cell. It cannot get out.
So what happens to all that trapped energy? Well, it's trapped for a very good reason. That glucose 6-phosphate is the perfect fuel to be fed directly into another process called glycolysis. You can think of glycolysis as the muscle's own personal, super-fast energy factory. This system makes sure the muscle has an immediate, on-site fuel source for a sudden burst of action, whether you're lifting a heavy box or sprinting for the bus. It's for the muscle's own use, and its own use only.
Which, of course, brings us right back to our main question. We have the same starting material, the same initial process, but two totally different outcomes. One molecule gets to travel the world, the other is on lockdown. So what's the one tiny little thing that makes all the difference?
And here it is. This is the secret ingredient, the hero of our story, really. It's an enzyme called glucose 6-phosphatase. The best way to think about this enzyme is as a molecular key. Its one and only job is to snip that little phosphate group off of glucose 6-phosphate, turning it back into regular, free glucose. It literally unlocks the sugar and sets it free.
And this says it all right here. It's so simple. Your liver has the key. It possesses the enzyme glucose 6-phosphatase, so it can unlock its sugar and release it into the bloodstream for the rest of the body. Your muscles, on the other hand, lack this enzyme. They just don't have the key. And because they don't have the key, their sugar supply stays locked inside as glucose 6-phosphate, ready and waiting for their own immediate use.
When you step back and look at it, what we have here is just a perfect system. It's an absolutely beautiful division of labor, all determined by the presence or absence of this one little enzyme. The liver gets to be the central energy bank, making sure your brain and other organs have a steady supply of fuel. And at the same time, the muscles get to be these self-sufficient powerhouses, always primed and ready for action. It's an incredibly efficient design, and it all hinges on one tiny molecular difference.
And hey, don't just take my word for it. To really hammer this home, a quote from our source material, Metabolism Made Easy, puts it perfectly. The liver is uniquely able to produce glucose from glucose 6-phosphate because it has glucose 6-phosphatase, whereas most tissues do not. I mean, it doesn't get much clearer than that. The presence of that one enzyme defines the liver's entire generous role in our body.
So this whole elegant system of sharing and saving energy, it all boils down to a single enzyme acting like a tiny switch. It's pretty amazing when you think about it, and it really makes you wonder, doesn't it? What other little molecular switches just like this one are silently and perfectly running your body right this very second?